Hello and welcome to one of my videos. I am Mr. Morton Science and today we are looking at GCSE Chemistry past papers. The paper we're looking at today is AQA C1 Higher Tier from June 2013 and we're going to be looking at question 1. If you want to work alongside this video then you just need to download the past paper from the link I'll put in the description, and you can choose to either watch the video first and have a go at the question, or have a go at the question first and then watch the video. Okay, so this is the paper. We're going to go straight to question 1. Aluminium has many uses. An aluminium atom has 13 electrons. Draw the electronic structure of the aluminium atom. Okay, so this is our atom here. And the important word here is the fact that it says it's an atom, not an ion, and it tells you how many electrons we need to put in. Now, when we're doing electron configuration, we need to remember that the first shell has got 2 electrons, the second shell can have up to 8 electrons, and the third shell can also have up to 8 electrons. Now we've got 13 to put in here, and we're going to start from the inside, so we need to put 2 in the first, we've still got some left over, so we can put up to 8 in the second one, that comes to 10, so we've then got 3 left over. The way we draw this on the diagram is that we put 2 crosses on the first shell, and we normally put electrons in pairs, so then we've got 2 on the second shell, another 2, another 2, another 2, that gives us 10, we've got our 3 remainder, and then we can put these individually. Now in an exam like this you've always got enough time to check, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, that's exactly how many we're meant to put on, so that will give us a mark. Name the 2 subatomic particles in the nucleus of an aluminium atom. This is looking at the nucleus of the atom here. If we had electrons on the shells, it kind of gives it away. The other 2 that we need to put in are in the nucleus, and these are going to be protons and the other subatomic particle that you can find in the nucleus are the neutrons. Fundamental question, you need to know that in the atom you've got your protons and your neutrons, and around the atom in the shells are the electrons. Part 3. Why is there no overall charge on an aluminium atom? Now, the thing that makes an aluminium atom aluminium is the fact that it has 13 protons. And you can check that using the data sheet it gives you. The periodic table, you find aluminium has got atomic number of 13, that means 13 protons. The protons are your positively charged particles. Okay, so we know it must have 13 electrons and 13 protons. That is what makes it, there's 13 electrons, that's what makes it neutral. So we've got the same number of electrons as protons. Okay, and that would get that mark. Okay, second part of the question. Rail tracks are made from steel. Molten iron is used to weld rail tracks. Important there is that it's iron. The reaction of aluminium with iron oxide is used to produce molten iron. So we're reacting aluminium with iron oxide, that's a compound, to produce molten iron, which is back to the element. This is the equation here. And we need to balance this. But the easy way to balance this one is because there's no gaps in front of here, we can't add any numbers here. So the small 2 after the Fe means that there are 2 Fe iron atoms in this compound. Everything we have on the second half of the equation must be on the first half, so these 2 here must go here, so we must have 2 iron atoms on the other side. Similarly, when we're trying to work out how many aluminium atoms we have over here, we can look over on the products. There are 2 aluminium atoms here, so there must be 2 aluminium atoms here. and that will get you this mark. Why does aluminium react with iron oxide? Now for this part of the question, they're expecting you to use the data sheet again. And on the first part of the data sheet, you've got a reactivity series. And if we're looking for iron and aluminium, we can see that on this reactivity series, iron is less reactive than aluminium, or that aluminium is more reactive than iron. What this means is that when they're reacting, the aluminium will replace the iron in the oxide. So why does aluminium react with iron? Aluminium is more reactive than iron. That'll get you 1 mark there. Total out of 5. Okay, check out some of our other videos. We're going to have a look at question 2 next, and I'll put the link in the section below.